Good morning, students. Today we are going to discuss about distance and displacement. Now, what is distance? This is starting point. This one is ending point, or I can call it as initial position. This is final position. Suppose if a person starts walking along the path length, if the person starts from the initial position and start walking along the path length and reaches at the other end, then I can call it as distance. Now you see the definition: actual path length traveled by an object in a given interval of time during the motion. This is called as distance. So next is displacement. Here the body initially is here. After a certain particular time, the body is in this position. So it has been moved. At least this body has been moved from one position to the other end. That is, from initial position to final position, it has been moved. That is called displacement. So here the displacement is vector quantity. That is, it has been moved from one end to the other end and the direction has been shown. So displacement is nothing but what? Final position minus initial position. So displacement is equal to what? Final position minus initial position. Now you see the definition. The difference between the final and initial position of the object in a given interval of time. There is one more definition for displacement. Before going into the definition, first we will see an example, then we will define it. Now this is a starting position and it is 4 kilometers or 4 meters. This one is the ending point and it will be 10 meters. There are three parts to reach this area. One, I can move from initial position to 10 meters towards in this direction. Or I can go from here to this area, that is for example 2 meters. Then I can turn it and then I can come back to the final position. This is another part. The third part, it will be here. I have moved to 3 meters. Then I covered in this. I moved in this direction. Then I reach to the final position. So there are 3 ways to go to the final position. Understood? So part 1, part 2, and part 3. So distance we will check it. In part, this is we consider part 1. This one we consider it part 2, and this one is third. Now I want to find out the distance for part 1. The distance is what? It starts at 4 meters and ends at 10 meters. So 10 minus 4, 6 meters. In part 2, you see from here it went 2 meters, then it crossed 4 meters. From here it is 4 meters, means there are also 4 meters. From here it is parallel, so it is 2 meters. So from starting point 2, and then it covered 4, then it covered 2 meters to reach the final position. So 2 plus 4, 6, 6 plus 2, 8 meters. The distance covered by the person is 8 meters in part 2. Now check for part 3. 3. This one is what? 10 minus 6. 10 minus 4 is what? 6. So 10 minus 4, 6. So like it means here 2. 10 minus 4 is 6. So 2 plus 6, 8. 8 plus 2, 10 meter. Then we get it 10 meter. Here 3. 3 plus 6, 9. 9 plus 3, 12 meter. Understood? Here you see the distance. Distance in path 1 is 6 meter, path 2 is 10 meter, and path 3 is 12 meter. So the distance changes. Here is in pathwise. Now, if I see the displacement, so what is the definition of displacement? Difference between final position and initial position. For path 1, what is the final position? 10 meter. What is the initial position? 4. So 10 minus 4, 6 meter. For path 2, this is the starting point, that is initial position, and this one will be the final position. So the displacement once again is 10 minus 4, that is 6 meter. For path 3, the initial position is 4 meter, final position is 10 meter, so the difference is 6 meter. Now if you see in distance, which one is the shortest distance? 6 meter. The shortest distance between what? The starting one and the ending position is nothing but what? Displacement. 6 meter means here you see displacement is of 6 meter. Now you see the definition. The shortest distance between these two positions of the object, and this direction is from initial position. This direction is from initial position to the final position during the given interval of time. This is another way of defining displacement. It is clear. Now we go for difference between distance and displacement. So you write the definition for distance here and displacement definition. Next point, unit. So for distance the unit is meter, and displacement also the unit is meter. The distance covers only the path length, that means magnitude, so it is scalar quantity. Displacement, it tells the direction, magnitude as well as the direction, that is from starting to the ending. So in which direction that person moves, then it is called vector quantity. Now you see the distance depends on path. The distance depends on path, but displacement, it does not depend on path. See the displacement, all the paths are same. So distance depends on path, but displacement does not depend on path, but it depends on the position. The displacement, it depends on the position. For example, now this is 2 meter, 1, 2 meter, 1 meter, 2 meter, for example. Now in the second part, just I increase the length. Now you see the distance depends on what? 2, 3, 4, 5, 6, 7, 8, 9, 10. So it becomes what? 10 meter. And so it depends on the part. But you see the displacement, initial position is 4, final position is 10. So the difference is what? 6. Suppose if the position, that is displacement, that is the final position, if the final position is here. Now you see the displacement 12 minus 4, 8. Here also will be 8, here also will be 8. So only if the position changes, displacement will change. So displacement depends on position, not depends on the path. This is the fourth point. Next we will go to sixth point. In sixth point, you see distance is always greater than. Distance is always greater or distance is always greater or equal to displacement. See that displacement are 6, distance is also 6. So distance is equal to displacement, and distance is greater than what? Displacement. Distance is greater than displacement. Here in that displacement is equal to distance, or displacement is less than the distance. Clear? Now we go to the fifth point. Distance in a closed path is never zero, and displacement it is 0. For example, take this is your home, this is your school, which is at a distance of 2 km. Now, morning you are starting from home and reaches to school, which is at distance of 2 km. And evening from school you are reaching to home. What is the total trip you covered? How much distance you covered? What is the displacement? So what is the distance here? What is the distance? Distance is nothing but what? Total path length covered. So total path length covered is what? From here to this 2 km. And from school to this, just you must take only the magnitude. So totally you cover 4 km. Understood? Now, this is a starting point. This is a starting position, and here itself or final position. Here will be the final position. So what is the displacement? Final position minus initial position. What is the final position? Here. What is the initial position? Here. So it starts at 0 km. So 0 minus 0, 0. So therefore the displacement is 0. Here. Next example. A ground which is of radius 50 meter. An athlete starts running and running at 3 rotations. What will be the distance and displacement? What will be the distance and displacement? This circle is in the form of circumference of a circle. So, what's the formula for circumference? 2 pi r. I can write 2 into 22 by 7 into what's the radius? 50 meter. This will give 1 rotation. This will give 1 rotation. This athlete, how many rounds he is making? 3 rounds. So multiply by 3. So what will be the distance now? 44, 15. So much meters that person covers. This is a distance covered by an athlete. Now what will be the displacement? What will be the displacement? So for displacement, if I want to find out, I should know the initial position as well as the final position. As the initial position, this one is the initial position. Where will be the final position? The same place we give what? Final position. So what's the formula for displacement? Final position minus initial position. So final position is 0, initial position is also 0. Therefore, the displacement is 0. Displacement vector in Cartesian coordinate system. Let us consider a plane, xy plane. Now, let us consider a point P1, which is from O. The position vector of P1 is R1 vector. Similarly, you consider a point P2, which is the distance from O, whose position vector of P2 is R2 vector. So, I can write the position vector of P1 vector is R1 vector, that is equal to x1i plus y1j plus z1k cap. Like that, position vector of P2 is R2 vector, that is x2i plus y2j plus z2k vector. Now, let us consider a particle is on P1. Now, this particle has been moved from P1 to P2, or the particle has been displaced from P1 to P2 in the direction of P1 to P2. Now, what will be the displacement vector? Displacement vector. So, we know that displacement vector is equal to final position minus initial position. Let displacement vector is delta r. So, I can write delta r vector is equal to final position is nothing but P2, the position vector is R2 vector minus initial position is P1 and position vector is R1. So, what is R2 vector? x2i plus y2j plus z2k minus R1 vector x1i plus y1j plus z1k. You subtract I coordinate y and yj and k. So x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 the whole k cap. This will give the displacement vector. Now, if I want to find out the magnitude, if I want to find out the magnitude, so delta r vector, the modulus, that is nothing but delta r, that is equal to square root of x2 minus x1 the whole time. Square this one, square is also we square it, plus y2 minus y1 the whole square plus z2 minus z1 the whole square. This will give the magnitude. Now let us consider an example. The point P is, what is the position vector of P? The position vector of point P is R1 vector, and that is on the x-axis is 1 and for y-axis it is 1. So I can write I vector I cap plus j cap. This one is I cap, this one is j cap. Then what will be the position vector of Q? It is R2 vector equal to 4I cap plus 2j cap. Now I want to find out the displacement vector. The particle is moved from P to Q. So this displacement is delta R. So delta R vector is equal to final position minus initial position. Final position minus initial position. That is R2 vector minus R1 vector. So R2 vector is 4i plus 2j minus R1 is I plus j. So 4i plus 2j, remove the bracket, so minus I minus j. 4i minus I, it becomes 3i plus 2j minus j, it becomes plus j. This will give the displacement vector, that is vector R. Now I want to find out the magnitude. So modulus of delta R vector is equal to delta R is nothing but square root of 3 square plus 1 square. So 9 plus 1, that is equal to 10 square root of 10 units. Now we will see what is calculus. Newton discovered this calculus. Newton originally is used to find out the motion of the planet around the sun. But nowadays, this calculus becomes an important tool in many of the applications in science and technology. Now, let us consider this graph of plane x, y, displacement, that is force displacement graph. Now an object is here. Initial position of this object is at A. Let us consider the initial position of this object is at A. Now I am applying a force. On this object, and this object has been displaced to a certain distance. And now the position of this object will be B. The object has been displaced. So, what is the work done here? Work done is equal to force into displacement. Here, force into. So, what is the displacement? What is the work now? How to find out the displacement? Final position minus initial position. So what is the final position? B. Initial position A. So I can write B minus A. So work done is equal to force into B minus A. Now, if you see this graph, it is in the form of a rectangle. It is in the form of a rectangle. Now this plane it represents A, and this one gives B minus C. This is length and this is breadth. Now, if I want to find out the area of this rectangle, area is equal to what? Length into breadth. So what is the length? Force. Breadth B minus C. Now you see these two equations. Here also F into B minus A. Here also F into B minus C. So I can say work done is equal to area under the displacement or force, displacement force, or I can write force displacement graph. I can write force displacement graph. Suppose if it is a regular shape, I can find out the area with the help of the formula. Suppose if it is an irregular shape, how to find out the area? How to find out the area? For this, we need calculus. So calculus is classified into two types: differential calculus and integral calculus. This differential calculus is used to find the slope of the tangent line to a curve at a point, or I can say to find the slope of a curve at a point, or even I can say to find the instantaneous rate of change, or to find the derivative of the function. That means what? Now, let us consider this is a curve, and here in one particular point I am drawing a tangent. Now, I will be finding out the slope for this. This will be actually slope. For this, you can use differential calculus. For integral calculus, it is used to find out the area under the curve or to find the area of the irregular shape. Now this is an irregular shape. Now if I want to find out the area, if I want to find out the area of this irregular shape, I can use integral calculus.